3.5, putting all together. So we want to see the steps to draw a function more accurately. We determine the zeros, x-intercepts and y-intercept of the function by putting them in a factor form of it. If this is irrational, you find the zeros in numerator for x-intercept, and for y-intercept, everyone knows for x we put 0 to find the y-intercept. Then we need to find maximum minimum point by taking the first derivative, and we want to find the inflection point taking the second derivative. Then we determine the interval of increase and decrease by finding the interval of the increase. You write the first derivative in factor form. Then you find the interval of the positive and negative. Positive means increasing, negative means decreasing. To determine point of inflection, you put your second derivative equal to 0. Also, the concavity, you just find the sign of your second derivative. Positive means concave up, negative means concave down. And then we sketch the graph from the information. Let's just look at the example. F of x is given x power 4 minus 5x3 plus x power 2 plus 21x minus 18. We use the knowledge of factor to find a possible factor. A possible factor is any number that is factor of 18. We guess, let's say 1. We put it there, or we put -1. See, f of -1 is 0. Sorry, f of 1. Because of 1 is a factor of 18, right? If we see f of 1, if you put 1 everywhere, is 0. Now do the long division, guess the next factors. Here is x. If I do the long division, it would be x minus 1. Then your quotient will be x power 3 minus 4x2 minus 3x plus 10. Again, I need to write this one a factor of 1. And again, I need to guess the factor. The factor of that is positive 3. If you put positive 3 here, this will be 0. Therefore, I can do again the long division. I will see the quotient is going to be x power 2 minus x minus 6. And this one is easy to write as a factor from find two number. That addition is -1 and multiplication is -6. So -3 and 2. Addition is -1, multiplication is -6. Anyway, you need to use your knowledge to write in a factor form. Now the zeros I can get it from this, right? From this bracket, the 0 is 1. From this bracket, the 0 is 3. Here is 3 as well. Here is -2. Make sure when your 0 here is x minus 3, the order of that is power 2. And you want a graph, you need to make sure it is like a turning. If this is 1, 2, 3, your function needs to turn here. At -2, your function passed through. At 1, it passed through, right? Make sure you know what is the behavior of each root there. Okay, so I'm taking the first derivative, power in front, power -1, again, power in front -1. I do that. This is the first derivative. I equal it to 0. Again, I need to use the long division. I'm going to guess a factor. If you put x3 here, so you get 0, right? Therefore, x minus 3 is the factor. You do long division, and that would be the result. So this one is the quadratic. I, again, write that in factor form. So you need to just find two numbers that addition is -3 and multiplication is 28. -28. So then from guessing these two numbers, these two numbers are what? 7 and 3. 7 should be negative because addition of that is that. The multiplication, it would be 28. Anyway, but since 7 and here, sorry, it's 7 and 4. 7 and 4 multiplication is 28 and addition is -3. That's 7 and 4. Then I need to divide that by the coefficient of the x power 2, which is 4. So I get -7/4, and here I get 1. I need to write it so the denominator will be the quotient of the x, and this number will be here. For this one, because the denominator here is 1, right? The quotient of the x is 1, and then plus 1. Here, what we have. Then we find the zeros. For 0 from the first one is 3, from that is 7/4, and from this one is -1. So these are maximum or minimum point. So you got this point, the x of that. How do I find a y? You just go back to your function. This is your function, right? Finding f of 1, f of 3, 7/4, f of -1. So these will give you a point of maximum or minimum. Okay. So I'm just going to erase this. Now, here we need to find the sign of our, so this is my f prime, so the zeros is -1, 7/4, 3. You write it from smallest to the biggest. You choose a point, a test point. Here you can choose 0. Sorry, here you can choose 0. Here you can choose -2 as a test point. Here you can choose 2.5 or 2.7 if you want, 2.7, and you can choose 4. For example, if you put 0 here, you get negative, because 0 is the negative, because 0 is positive, negative, positive, so it's going to be positive. The same thing, you put it there to find the sign. So from here to here is decreasing, increasing, decreasing, increasing. So at -1, we have a minimum. See, we have minimum. At 7/4, we have a maximum. And at 3, we have minimum again. So we can do the second derivative, take like having the first derivative. We can do the second derivative and we can write it in a factor form. When you write in a factor form, then we can find the sign of that to investigate the concavity. Also, you need to do the inflection point. At the zeros here is 0.07 and 2.43. You can find the f of 0.07 to find that point of inflection, f of that, to accurately find that point of inflection. Anyway, the zeros we had, it was, the zeros we had, it was -2. The y-intercept we got, we put for our function x0, and then we see that is -18. So this is the y-intercept. Here is 1 of the zeros, 2, 3 is another zeros. You see, since we had a minimum at what point? 7/4, right? And at -1, here at -1, we have minimum, make sure. And this is what is happening. We have a negative, have a minimum here. And then at 7/4, we have a maximum. Then we have to go through 1. And then, as you know, we have to turn here. This is the double root order 2. The 0 is the order 2. I went to the previous slide. So at f of 3, we have extremes at 7/4 and at -1. I need to modify my graph. Guys, here is, I'm gonna erase that. Take this part. So as you see, at f of 3 is 0. That one, that is no maximum. And at 7/4, we have local maximum. So we go through this, and here we have maximum 7/4. It's LL, it's the LL less than 2, so there. And then here at 3, we have again local minimum. Make sure, guys, this is the x minus 3 is a double root, that's why I turned. At x plus 1, here you have to cross because the order of this bracket is 1. At -2, you have to cross the x-intercept because the order is 1. And we have done that there as well. So yeah, -1, 7/4, 3. And these were inflection point that you can show in your graph. Basically, this is one of the inflection points, 0.07. And another inflection point, you have there 2 point something, right? Here is that. And this is how we can use this to graph first derivative, second derivative to graph a function.